Welcome back, 6th graders. Today we're going to be looking at building off what we've been doing and actually starting to make predictions. By the end of this lesson, you want to be able to predict the actions of a larger group using results found in a sample. So first of all, a survey is a method for collecting information. Most of us are pretty familiar with surveys. They're something that we fill out online, or you might fill them out at a store, you might take a telephone survey. Basically, it's just to gather information that we're looking at. The population is a group being studied. And populations can mean different things. And then the sample is a part that is surveyed, and it's part of the larger population. So let's look at some examples, and I want you to file each as a population or a sample. If I'm looking at a city, people in a restaurant, students in 6th grade, and all students at presentation, what do you think those would be, populations or samples? I'm going to go ahead and pause the video and try this out on your own. Let's start with a city. So a city would be a population. Pretty nice, because if you think about it, outside city limits, it says population so many thousand, kind of makes sense. People in a restaurant, depending on what we're looking at, might be a population, but more than likely it's going to be a sample. Because it's just a small gathering. Students in 6th grade, once again, would also probably fall under the category of samples, and all students at Pres would be a population. The thing about samples and surveys and stuff like that is that we have to be careful about how we're collecting the information. And there's some things that you should keep in mind when you are taking samples. Good samples are selected at random without preference, meaning nobody has a better chance of getting selected than anybody else. They should be representative of the entire population. So for example, if we look at the students in 6th grade, that's not really very representative of the entire population of the school. And then lastly, it should be large enough to provide accurate data. So a sample of one person would not be very accurate because you can't really create averages from that. Now I want you to read through these following situations and see if you can answer the questions on your own, and then check your work. So a car dealership sells 4 hybrid cars in a week. Pretty good. So we want to know, how many hybrid cars would you expect them to sell over 2 weeks, and why do you think that? Well, if they're selling 4 in 1 week, we can almost think about scaling like we've been doing to 2 weeks. Since 1 times 2 is 2, 2 times 4 would be 8. So we would expect them to sell about 8, because it'd be double the amount of weeks. So what is your prediction for the number of hybrid cars that they would sell in 10 weeks? So once again, if we had 4 in 1 week, we wanted to know how many in 10 weeks. This would be times 10 times 10. So we'd expect them to sell about 40 cars in 10 weeks. And really what this is showing is that we can use samples to make predictions. Does that mean they're for sure going to sell 40 cars? No, not at all. But we're just kind of making a prediction because maybe it's a trend that they've been seeing. So in a recent survey at a school, they found that 6 out of every 10 students have a cell phone. We want to know, what is the probability a randomly selected student has a cell phone? So we have 6 out of 10. Which reduces to 3 out of 5. So the probability, if we change that to a percent, we can either take the 10 or the 5, would be about a 60% chance. If there are 250 students in the school, about how many would we predict to have cell phones? So if I left it with the 6 out of 10, I'm going to use the 3 out of 5. I'm going to use a proportion, so 3 out of 5 has to be the same out as 250, because these are, I'm going to keep like to like, so part out of the whole, and I want to know how many out of the 250. So 5 times 50, because 5 times 5 is 25 plus a 0, would be 250. 3 times 50 is going to be 150. So we would expect about 150 students to have a cell phone. Now I want you to go ahead and pause the video that I've got, since I've gone through that, read through the next situation, and see if you can answer the question on your own. I conducted a survey of every 6th person in the cafeteria to name an activity they would like to do for a spring outing. I want to know what is the probability they would prefer an amusement park. If there are 408 students at the school, predict how many students would prefer an amusement park. So a favorable outcome for an amusement park would be 15, but we have to figure out how many total were surveyed. So we have 10, 20, 5, 35, 40. So we have 15 out of 40, which would reduce to, divisible by 5, 3 out of 8. So 3/8 of the students preferred amusement parks. But I want to know if there's 408 students in the school, how many we would expect that. Now I could do what times what equals 408, or I could also use my cross products, which I'm going to do here. So I'm going to do 3 times 408, just to give you a different look. It has to be 8 times x, because we don't know what that number is. So if I do 3 times 408, I get an answer of 1,224 equals 8x. So then I'm going to do that dividing piece and divide by 8, and I get 153 students. So I would expect about 153 to prefer the amusement park if I pulled the entire school. Go ahead and leave a question on Edmodo, and I'm sure you'll probably have some because it's been kind of tricky, and we will discuss this more tomorrow.